So here we have a subset of the data that we wish to investigate. We have one pairing of data where we have some observations that were taken above a sewage works and some observations that were taken below the sewage works, and we might perhaps be interested to see whether the amount of dissolved oxygen was lower below the sewage works, and we wish to perform some kind of hypothesis test on this. So again, first thing we might want to do is just do a little check of the data we've got. So we'll display some descriptive statistics, and we will look at dissolved oxygen, and we'll look at it by location. And if we run this through, we find that we've got 5 observations for each, and the mean at site DSTW is 75, the mean at site USTW is 87. One thing we might be a little concerned about is that the standard deviation at these two sites does look like it might be very different. For now, we'll just note that and think about that later. We could again do some kind of graph. With a larger data set we might do a box plot. Small data set, we'll just do an individual values plot. Again, we have groups. We're interested in dissolved oxygen, and we're interested by location. If you have a look at the plot, this is telling us something about the data that we've recorded. Okay, so we won't save that graph, we were just doing a little check ourselves, but now we want to perform a particular test, and under basic statistics it let us conduct something called a two-sampled t-test. And the whole idea here is that we're trying to test the null hypothesis that both samples were taken from the same environment, and if we reject that null hypothesis we conclude that they're very different. The same pattern in the menus, in that we enter a box of the variable we're going to measure, and then we need the grouping variable. The only problem here is Minitab's changed the names, but this is basically the y variable, this is the grouping variable. And if we hit the OK button, it goes off and conducts a two-sample t-test. It tells us that it's looking at the difference between DSTW minus USTW, and that it estimates the difference is around minus 11. So this indeed implies that USTW is larger. There's a confidence interval for the difference, and in terms of what we're looking at the moment, it carries this t-test, and it computes a test statistic called a t-value, and this test statistic is minus 12. And what we ask ourselves, how plausible is that test statistic? How is it far enough away from 0 that we're entitled to reject the null hypothesis? We get this p-value that tells us, to rounding error, the probability is 0.000. So somewhere in the 4th, 5th, 6th decimal place there's some interesting numbers, but it's rounded it to 3 decimal places and told us the probability is 0.000 something. It is much less than 0.05, so the probability of us getting a t-value as large or as negative as minus 12, if the null hypothesis is true, is less than 0.05. So we're entitled to reject the null hypothesis and conclude that there is something substantially different in the dissolved oxygen at site DSTW compared to USTW,